Hey, Algebra 1, we got Unit 1, Lesson 2. Let's jump into the homework. A lot of today has been about equivalent equations and looking at how you can take one equation and transform it into another one. It's really like as we're solving equations, what are the steps of solving an equation that keeps it equivalent? So let's actually jump on down to this one. I asked you to do 1 through 8, but let's jump on down to this one. How would you solve this? You actually have two ways that you could solve it. We could simplify this side and do 3 times x, 3 times 2, or we could also get rid of that 3 on the side, divide by 3. Over here, these two numbers are not divisible by 3, so I wouldn't do that. I would distribute this one first. Since that's something that's just simplifying the side, we don't have to do anything to the other side. We still get the 26 minus 2x. And on the other side, we get 3 times x is x, 3 times 2 is 6. So 3 times x is 3x plus 6. Now we've got x's on both sides. What we saw in today's class is that we could add and subtract x's from one side or another, then make them cancel out. And so here's the thing: if we add 2x on this side, that will cancel out with a negative 2x, and add 2x on the other side, that will keep it balanced. This is now where we have to balance things out. And so 3x and 2x would make 5x plus 6. And on the other side, we'd have 26 is equal to that. This becomes pretty easy because now we're like, oh, well, okay, we can take away 6 and take away 6. We get 20 is equal to 5x. And then when you solve that, you're like, okay, 5 times 4 divided by 5 divided by 5. 5 times 4 would be 20, or 20 divided by 5 is 4. X is 4. All right, so again, we're looking at equivalent steps along the way. Let's jump into this one here. So how could we simplify this? Since 4 and 6 are divisible by 2, that's actually going to be the preferred way of starting this one. I could multiply by 2 to undo that, and the 4x and the 6 would come down, and I'd multiply this by 2. But because these are both divisible by 2, that's the easiest thing to do. 4x divided by 2 is 2x's. 6 divided by 2 is 3, so negative 3. And the other side stays the same because all we were doing is simplifying the side. Now we are going to be doing stuff to both sides. I have to choose. I want my x's to be on this side. I have more x's, so this is 1x that I'll take away 1x from the side and take away 1x from the side. That actually is really nice because 2x minus 1x is just 1x, which is just x. And I'm going to be a little advanced here. There's another thing that we could do in this step. In this equation, I could start to move this 3 onto the other side. I could do that as a whole separate step, but I could add 3. That's the opposite of subtracting 3, and add 3 to this side. Negative 8 plus 3. Negative 8 plus 3 would be negative 5, and that is our solution. X is equal to negative 5. Okay, and this one. When I'm looking at this, we have a fourth x minus 5 equals x minus 14. I don't really like that 1/4 there. So we could quadruple everything. If I made this 4 times bigger, if I multiplied this by 4, and did everything by 4, 4 times a fourth is 1 whole x, 1x. 4 times 5 would be 20. 4 times x would be 4x, and 4 times negative 14. Negative 14 times 4, what do we get? Negative 56. Now, I know that I made all the numbers larger, but now I don't have a fraction in there. We could have solved this another way, but I'm using equivalent equations in order to set this up and kind of get rid of the fractions. Okay, now, I'm going to take away 1x from this side and take away 1x from that side. At the same time, I am also going to, look at, this doesn't, this is a 56, my gosh, I'm an idiot, 56. Okay, at the same time, while the x's leave on this side, and 4 minus 1x would be 3x, I'm also going to add 56 to get that out of the side, but I'll add 56 to the other side. This is where we're doing stuff at both sides of the equation. So I'll have 56 minus 20, that would be 36, or negative 20 plus 56. The next step is to divide by 3, and 36 divided by 3 is 12. We get x is equal to 12. Okay, So again, this was one where I chose to start differently because of the ugly numbers. Now let's go back up to the top. Let's start with number 1. We'll finish the page. Which equation is equivalent to 6x plus 9 is equal to 12? Well, let's see. They're both, all of these are divisible by 3. So like 6x, that would be, divided by 3 would be 2x, divided by 3 would be 3, and divided by 3 would be 4. This one is equivalent to it because each one of these is, you know, like this one, they cut the 6 in half to make 3, they cut the 12 in half to make 3, but they didn't cut the 9 in half. They should have done that. So the other ones are not going to match up, but that one does. That one is equivalent to this. They're the same. Write another equation that's equivalent to this. My gosh, you got so many options. You could take the whole thing and multiply everything by something, or I could take this whole thing and divide it by 3. Why 3? Because all of these are divisible by 3. So, you know, so let's see. Yeah. Oh, actually, that's actually what they did here. So I don't want to do that. Let's see. Let's make something different. How about I just double everything? So we could have a 12x, an 18, and a 24. That would be fine. That's mathematically equivalent. Let's move on. Select all of the equations that are equivalent to this ugly little thing. Okay, looking at this, you could take that -8 and a -6, divide them both by 2, and I get -4 and a -3. So -4 and -3 and a 15. This one is one that's equivalent. Let's see. Switching the signs on this would not be equivalent. All right, so these both switch signs, but then the 15 would also have to switch signs. So that one I can tell, I can rule it out. Let's see, what else could we do with this? We could take this 2 and instead of dividing these by 2, leave them the same, but then multiply the other side by 2 to make it 30. And this one here has these parts as the same, but double that. This one is equivalent. Let's see, what else? 8x, 6, 30. I'm not seeing any others that are equivalent, just those two. All right. Okay. Paz made a mistake when solving this equation. What's their mistake? So we got their work here. And it's like, okay, if they have this is the same, then what they must have done is they must have divided by a -3 and divided by a -3, but they didn't. What they did was they added 3. They added 3 by accident, but they should have divided by -3. 24 divided by -3, what's that? That'd be a -6 they should have gotten here. So that's their error. And what's one thing that they did? Oh, that's what they did incorrectly. What's one thing that they did? Well, I guess once they got down here, the idea that subtracting 7 to get 20, if even given that mistake, that was the right thing to do. Yeah, okay. Hey folks, hope that made sense. The big thing is, like, can you solve equations, and then can you find equivalent ones by manipulating the equations in disguise? Take care.